which means the hash value also be changed. So if the hash value is changed, it will be notified to the next block, and that block hash value will also be changed. Okay, so like that, the tampering of data, it is not possible with respect to blockchain network. Okay, so you'll have a private key to access the data, but will have a public key to make a transaction. Even though you provided with a private key in order to access your data, but for doing a transaction inside the blockchain network, you need a public key. Okay, so this is how there will be nowhere to hide. Although the case for private or federated blockchain is a bit different than your public blockchain, but still, in those cases, many people can see what really goes on in the ledger. So that's because the ledger on the network is maintained by all other users on the system. This distributed computational power across the computer to ensure a better outcome. So that is the reason it is considered one of the blockchain essential features. The result will always be higher efficient ledger system that can take on the traditional one. Then the fifth one is consensus. Okay, so every blockchain grows strongly because of the consensus algorithm. So the architecture of blockchain technology is cleverly designed, and consensus algorithm are at the core of this architecture. Every blockchain has a consensus to help the network make decisions. Okay, see for example, if a newcomer is coming in order to make part of your blockchain networks. Okay, so in that case, every rest of the block holders will execute their consensus algorithm in order to make a decision whether to allow a newcomer or not. Okay, so such kind of activity is happen only because of consensus algorithm. Okay, so in the upcoming slides, I have a couple of slides about consensus algorithm. I think that time you'll get a clear picture of what actually the consensus meaning. Okay, and in simple terms, I can say that consensus is a decision making process for a group of nodes active on the network. So, here the nodes can come to an agreement quickly and relatively faster without to allow a newcomer. So, that decision can be taken quickly and fastly. So, when millions of nodes are validating a transaction, a consensus is absolutely necessary for a system to run smoothly. So you could think of it a kind of voting system where the majority wins and the minority has to support it, right? So the same is applied for in the blockchain network also. And nodes might not trust each other sometimes, but they can trust the algorithm that run of the core of it. So that is why every decision on the network is a winning scenario for a blockchain, and it is one of the benefits of blockchain features. Okay, so the last one we have a faster settlement. So in the traditional banking system are quite slow, right? Sometimes it can take days to process a transaction after finalizing all settlement. It also can be corrected quite easily. Blockchain offer a fast settlement compared to traditional banking system. This way, a user can transfer money relatively faster, which saves a lot of time in the long run. So these blockchain features make life easier for foreign workers and help to understand why blockchain is important. So, many people travel to another country in search of better life and job and leave families behind, right? Okay, so however, sending money to their families overseas takes a lot of time and could become fatal in times of need. So now blockchain are very too fast, uh, and they can easily use it to send money to their loved ones. Another fun fact is that we have a smart contract system in the blockchain technology. We have smart contract system This can allow making faster settlement for any kind of contract. So this is one of the best benefits of blockchain features to this day. And with the third party out of the way, people can send money with a minimal fee. Seems or it is right? We don't want to pay excess amount to the third party in order to transfer money from one place to another place. So straight away we can do the transaction to our beloved ones, right? Okay, so these are the core, the like important key features with respect to blockchain technology, starting from immutability, decentralized, enhanced security, distributed ledger, consensus, faster settlement. Okay, so these features enable people to work more on blockchain technology. They can they can adopt blockchain technology into their application or business. And the components of blockchain. Okay, so these are the things. Some words we already come across, right? Node, transaction, block, chain, and consensus, right? Okay, and I think minus, that is the new word appears in this slide, right? Okay, so okay, let me explain one by one. Like node, actually, node is nothing but we can say it is a user or a computer within the blockchain. And transaction, it is nothing but a smallest building block of blockchain system. So transaction is nothing but what activity or what action we are performing on blockchain with respect to our data. So that is nothing but a transaction. For example, if you want to transfer money from your account to your friend account, then the transferring the money is one of the transaction. Okay, so that has to be approved by the rest of the block holder. Like for example, I'll tell you one scenario, right? Let's say we have three friends. Let's name it as X, Y, and Z. Okay, so in the beginning stage, we in the blockchain network we have only two members, that is X and Y. They have like each of them are having 100 rupees. Okay, so let's say 100 rupees. Okay, X having 100 rupees and Y having 100 rupees. And suddenly like the other person, let's say Z, is joining into that block network, and he is having only 50 rupees. Okay, so now the X knows how much the Y and Z has the same thing, and vice versa. Y know how much X and Z has. Okay, so everybody knows the other's amount. Okay, so in that case now like Z. Okay, let's say Z is a cheater one. Now he is putting a transaction like I'm going to transfer the amount 150 rupees to the account X. So now the X and Y have to believe. Will they believe? Because they know that the Z have only 50 rupees. So now the transaction is invalid. They will not allowed to perform this transaction, right? Okay, so this kind of security, then we can avoid such kind of cheating actions, right, in the blockchain networks. Okay, so that is transaction. If you want to perform any transaction, it should be validated by the rest of the block holders, right? Then the block actually a data structure. It is used for keeping a set of transaction which is distributed to all nodes in the network. And chain, it is nothing but a sequence of blocks in a specific order. Then miners, so that is the new word, right? Okay, so the miner is nothing but a specific node which perform the block verification process. Okay, so if new block is coming into the your network, the person is a right person to join the network. Their identity will have to be validated, right? Okay, so that kind of validation will be taken care by your miners. Not only the identity, if you are performing any transaction, will it be a valid transaction or invalid transaction? Everything can be taken care by your miners. So sometimes miners, that is, every node in a blockchain network can be a miner, or we can allow certain nodes to be a miner. Those nodes will take care of validity and verification process. Okay, then we have a consensus. It is nothing but it is a set of rules and arrangements to carry out blockchain operations. Okay, so that's about your core components of blockchain and how the blockchain works. Like as I said, like whenever a person wants to perform a transaction, first the transaction is requested. That is the first process. Okay, so now a block that represents the transaction is created. Okay, so the block for a transaction is created, and the block is sent to every node in the network. Okay, that is for validating the transaction, whether will it be a valid transaction or invalid transaction. So that will be first send it to every node in the network, and the node validity transaction. If the every node accept that the transaction is valid, then the corresponding node receive a reward for the proof of work. That is, proof of work is nothing but validating the transaction, whether it is a valid transaction or invalid transaction. To find that, we'll be having a certain procedure. That is nothing but proof of work. Okay, so once the transaction becomes a valid transaction, the corresponding node receives a reward for the proof of work. After that, the block is added to the existing blockchain, and finally the transaction gets completed. So this is how the blockchain works. So to perform, that is from the start, if the transaction is a node wants to perform a certain transaction, the request will be sent to the rest of the node in the network. Then those nodes will validate the transaction, and then the corresponding node which generated the request will receive the reward, and then the block is added to the blockchain, and finally the transaction gets completed. Okay, so this is how the blockchain network works. Okay, so then the blockchain structure. Okay, in the beginning I told you like a blockchain will have three fields, right? Okay, so this is how the blockchain structure looks. It is first one as a block header, then hash of previous block header, and a Merkle root. Actually, the Merkle root is nothing but we have a Merkle tree data structure. It is similar to your binary tree structure where we'll be having a root node and a leaf node. So Merkle root is responsible for calculating the hash value of a particular blockchain. As I said earlier, the hash value is computed based on the data available in the block. Okay, in every block we'll be having a certain data, right? Okay, so according to that, the value of the data, the hash value is computed by your Merkle tree. Okay, so, like in the leaf node, we'll be having a hash value of every transaction or every data in a block, and at the top, we'll be having the consolidator hash value of a particular block. Okay, so if you see the block one, in the top in the block one header, that is nothing but your hash value of your block. Okay, so that will be pointer to the hash of previous block header in the block 2. So this will be continued until the end of the block in a blockchain network. Okay, so that's about your blockchain structure. So the next, coming to the evolution of blockchain. Um, yes, is there any doubt so far? Shall I continue with this content?
Yes, ma'am.
Yeah. Okay. See, the next is like evaluation of blockchain. Like it is started. So initially, I told you like the concept of blockchain. It is started in the year 1991, right? Okay. So how did blockchain emerge? Like we have some persons like Scott Stone Tap. They envisioned what many people have come to know as a blockchain in 1991. The first work involved in blockchain was working on a cryptographically secured chain of blocks whereby no one could tamper with the timestamp of documents. In actually in 1992, they upgraded their system to incorporate Merkle trees that enhanced efficiency, thereby enabling the collection of more documents on a single block. Okay. However, it is in 2008 the blockchain history starts to gain relevance. Thanks to the work one person or group by the name of Satoshi Namakuta. Actually, he is the person who discovered the blockchain concept again. Though it is started in 1991, but it is known to the world only through this person, like Satoshi Namakoto. So he's accredited as the brain of behind blockchain technology. Very little is known about Namakoto, as people believe he could be a person or a group of people that work on Bitcoin. That is the first application of digital ledger technology. And conceptualized the first blockchain in 2008, from where the technology has evolved and found its way into many applications beyond cryptocurrencies. Initially, it started with cryptocurrencies. Later, many applications adopted blockchain technology into it. And he released the first white paper about the technology in 2009. So in this white paper he provided details of how the technology was well equipped to enhance digital trust, given the decentralization aspect that mean nobody would ever be in control of anything. uh, ever since he exited the scene and hand over Bitcoin development to other core developers, the digital ledger technology has evolved, resulting in new applications that make up a blockchain history. Okay, the first one is the transaction from only from the cryptocurrency to other application. Um, the next is like evolution of blockchain, like between 2008 to 2013. Most people believe that Bitcoin and blockchain are one and same thing, but however, that is not the case, as one is the underlying technology that powers most of the application, whereas the other one is the cryptocurrency. Bitcoin is the cryptocurrency, and a blockchain, it is a technology which powers most of the application. And Bitcoin came into being in 2008 as the first application of blockchain technology. Uh, Satoshi Namakuta, a white paper titled it as an electronic peer-to-peer system. He has formed a Genesis block from which other blocks were mined, interconnected, resulting in one of the largest chain of blocks carrying different pieces of information and transaction. So when it comes to the 2013 to 2015, the Ethereum development happened. Actually, in a world like where innovation is the order of the day, like we have like Putrin. Okay, so he's among a growing list of developers who felt Bitcoin had not yet reached there when it come to using the full capabilities of blockchain technology as one of the first contributor to Bitcoin code base. The Ethereum was born out as a new public blockchain in 2013 with added functionalities compared to Bitcoin, a development that has turned out to be a pivotal moment in blockchain history. So he differentiated Ethereum from Bitcoin blockchain by enabling a function that allows people to record other assets such as a slogan or music as well as contract. Okay, so anything can be made available in the blockchain networks, not only the cryptocurrency, any data. It may be your slogan or it may be any music, anything can be made available in the blockchain network. So the new feature expanded Ethereum functionalities from being a cryptocurrency to being a platform for developing decentralized application as well. And officially launched in 2015, the Ethereum blockchain has evolved to become one of the biggest application of blockchain technology, given its ability to support a smart contract used to perform various functions. Ethereum blockchain platform has also succeeded in gathering an active developer community that has seen it establish a true ecosystem. So Ethereum blockchain process the most number of daily transactions thanks to its ability to support smart contracts and decentralized applications. And finally, we have like in 2018 applications. Okay, so we are started to adopt more application into our blockchain network. So blockchain history and evolution does not stop with Ethereum and Bitcoin. In recent years, a number of projects have propped up all using blockchain technology capabilities. A new project have sought to address some of the deficiency of Bitcoin and Ethereum, in addition to coming up with new features leveraging blockchain capabilities. The blockchain history discussed here involves public chain networks whereby anyone can access the content of a network. Okay, so whatever the blockchain we discussed from since 2008 to 2015, all are belongs to blockchain, public blockchain networks only, where you know that where anyone can access the content of a network. However, with the evolution of technology, the number of companies started adopting the technology internally as a way of enhancing operational efficiency. So the large enterprises are investing big in hiring professionals as they seek to gain a head start on use of this technology. Companies like Microsoft, right? So Microsoft appear to have taken the lead when it comes to exploring blockchain technology application, resulting what has to come to be known as a private, hybrid, and federated blockchain technology. And in 2015, also there is a new concept arrived in blockchain technology, that is a hyper ledger. So in 2015, the Linux Foundation unveiled an umbrella project of open source blockchain. They went on call it as a hyper ledger, which until to date act as a collaborative development of distributed ledgers. Like hyperledger is nothing but the collaborative development of distributed ledger. It seeks to advance cross-industry collaboration for the development of blockchain and distributed ledger. So mostly the Hyperledger focuses on encouraging the use of blockchain technology to improve the performance and reliability of current system to support a global business transaction. And at the end, blockchain history and feature, that is after 2018 or after 2020. Actually, sorry, it is supposed to be to 2020, not 2018. The future of blockchain technology looks bright in part because of the way the governments and enterprises are investing big as they seek to promote innovation and application. It is becoming increasingly clear that one day there will be a public blockchain that anyone can use. The evolution of blockchain technology in recent years has increased the demand for blockchain professionals. The companies are also implementing blockchain to get benefits of blockchain applications. To build that's how it is started in the year 1991. Though it is started in the year 1991, but nobody were aware of what actually the blockchain means. But in the year 2008 only, it is again started with the application of Bitcoin, and now application of Bitcoin in the cryptocurrencies. But now the blockchain it is made available every applications in the real time. Okay, so that's about the evolution of blockchain, and we'll move on to the next slide, which tells about smart contract. As I said, we already come across this word, right? Smart contract. What is the meaning for smart contract? Actually, we were well aware of what actually the contract means, right? Okay, so whenever we are buying any house, or we are moving to a new house as a tenant, okay, so we'll be made some agreement between the house owner and the tenant, right? Okay, so the same is a smart contract. Okay, so that is here in the digital manner we'll be making the agreement between two parties, that is smart contract. Okay, so while a traditional contract require both parties to execute their responsibilities, smart contract self execute predefined action when specific conditions associated with a given transaction are met. Like for example, if you're a landlord, your tenants have leases. Okay, so the smart contract contains a key data of both parties, such as a name, contact information, a bank account detail, as well as the information about the lease itself, including lease amount and the payment date. Anything is available in the smart contract. So now the job of a smart contractors, when a smart contract self executes on predefined lease payment date. So every month we'll be paying our lease, we'll be paying the amount, tenant amount, right? Okay, so when a payment date comes, the smart contract, it automatically withdraws funds from the tenant's bank account and deposit the funds into your account. So this saves you the monthly rental statement in advance, and reminding, we don't need any to reminder the tenant to pay, and from haunting the tenant once the late date has passed, and then never mind the eviction notices, court date. Okay, so anything it's done automatically. Okay, we don't need to remember when to pay and when to a particular agreement is expired. Okay, so everything once we made a smart contract, it is self executed automatically when a particular condition met. Okay, so what do smart contracts have to do with blockchain? So the smart contracts are kept on the blockchain and are executed automatically when a transaction is processed. And because data on the blockchain is immutable, and it cannot be changed or manipulated by anyone, so smart contract is once agreed upon should help build trust between all parties, as neither side can play with the contract or its term. So this diagram shows like first will be making terms and details of agreement are coded in a smart contract. So actually, smart contract is nothing but it is a script, or we can say it is a programming a code and the event or action trigger. Then the particular code will be executed. Okay, that is the execution of contract. Then a smart contract is auto executed based on pre-agreed terms and actions such as payment, notification, API call, or everything is processed automatically. The transaction settlement and clearing are completed instantly. So once the smart contract is executed, the settlement everything is completed quickly. Okay. So the benefits of smart contract. Okay. So we'll start with like here autonomy. That is the first one is the autonomy. I hope the picture is not clear, but I'll explain everything in detail. The autonomy, you are the one making the agreement. There is no need to rely on a broker, a lawyer, or other intermediaries to confirm. This also knocks out the danger of manipulation by the third party, since execution is managed automatically by the network rather than by one or more. Then the next benefit is trust. Your documents are encrypted on a shared ledger. There is no way that someone can say they lost it. Okay. Then the third one is backup. Imagine if your bank lost your saving account. What happened? We could not do anything, right? So whereas on the blockchain, each and every one of your friends have your backup. Your documents are duplicated many times over. Then safety. So safety like cryptography, the encryption of website keeps your documents safe. There is no hacking. In fact, it would take an abnormally smart hacker to crack the code and infiltrate. Then speed. You would ordinarily have to spend chunks of time and paperwork to manually process document. But in case of smart contract, it uses software code to automate a task, thereby saving hours of a range of business process. Then finally, the savings. So smart contracts save your money since they knock out the presence of intermediary. You, for instance, have to pay no notary to witness your transaction. And finally, accuracy. It automated contracts are not only faster and cheaper, but also avoid the errors that come from manually filling out heaps of forms. So these are the benefits of smart contract. So next we'll see the pros and cons of smart contract. We already discussed about the advantage of smart contract, right? So accuracy, saving, autonomy, trust, backup, safety. In addition to that, the security, the economy, and speed, and standardization. There is a wide range of smart contract nowadays. You can choose one and change it according to your needs. So that is the advantage of a smart contract. Then disadvantage of a smart contract is human factor. That is, people who write the code can make mistake. If the smart contract is in the blockchain, it does not change. Okay. Then uncertain legal status. So currently, no government is regulating smart contract. So as a result, there is a potential issue if governmental institution decide to make a legislative framework for smart contract. Okay. Then implementation cost. It is one disadvantage of very big disadvantage of smart contract because the smart contracts cannot be performed without programming. It is very important to have an experienced coder on the staff to make approve smart contract and adopt the internal structure of the company for blockchain technology. Okay, so now that we have discussed the pros and cons of smart contracts, so let's look at where they can be applied. that is smart contract application. We can apply it in different field such as election, logistics. Okay, so election in the sense like voting procedure can be complex, as we know that, right? So however, when voting results are put in the blockchain and distributed among the nodes of the network, they remain anonymous. They will also eliminate any manipulation with the ballot. Then when we say about logistic, as we know that the supply chain includes a lot of links. In addition, each link has to get confirmation from the previous one, holds up its end of the contract, and they send the information for. Also, it takes a lot of time to do the work on time. So whereas in the small contract, it ensures transparency in the contract terms as well as a fraud protection. So there are some other possible application that is in management, bank system, insurance, estate, then then IoT, and so there are a lot of applications where we can apply smart contracts. Okay, so next we'll discuss about conse- consensus algorithm. Okay, as we already discussed that consensus is one of the core important feature in blockchain. We know that. A blockchain, it is a distributed, decentralized network that provide immutability, privacy, security, and transparency. So there is no central authority present to validate and verify the transaction. Yet, every transaction in blockchain is considered to be completely secure and verified. So this is possible only because of the presence of consensus protocol, which is a core part of any blockchain network. So a consensus algorithm, it is a procedure through which all the peers of blockchain network reach a common agreement about the present state of the distributed ledger. So in this way, the consensus algorithm achieve reliability in the blockchain network and establish trust between unknown peers in a distributed computing environment. So essentially, the consensus protocol makes sure that every new block that is added to the blockchain is the one and only version of the truth that is agreed upon all the nodes in the blockchain. So the blockchain consensus protocol consists of some specific objectives such as coming to an agreement, collaboration, cooperation, then equal rights to every node, and mandatory participation of each node in the consensus process. So thus, the consensus algorithm aims at finding a common agreement that is a win for the entire network. So we do have lots of consensus algorithm. So according to our requirement or according to the application, the type of what consensus algorithm we use it differ. So these are that we have lot of consensus algorithm, out of which these three are very important. Like most of the application are preferring to use these three consensus algorithm in their application. And the first one is proof of work. Okay, so the proof of work is currently the most common and one of the most robust consensus mechanism for blockchain technology. Here, the miner has to solve a mathematically complex puzzle on the new block before approving the block to the ledger. We already discussed now, they need to solve some mathematical puzzles. Okay, so before joining into that blockchain network, then they need to do some home practices. Then after solving the puzzle, the solution is then forwarded to other miners. You know who is miner, right? Okay, and verified by them before being accepted to their respective copy of the ledger. So the transactions are finalized and approved by the miners after verification. Only then the blocks can be added to the blockchain network. Okay, so the next one is proof of stake. So the proof of stake is nothing but it is a substitute approach of proof of work, which require fewer CPU computation for mining. Though this is also an algorithm, the purpose is same as proof of work, but the process is quite different here. That is, um, in case of proof of work, a miner is rewarded by resolving mathematical problem and creating new block. Whereas in proof of stake, the creator of a new block is chosen in a deterministic way depending on its wealth and also defined as a stack. So this means that in POS mechanism there is no block reward. So the miner takes the transaction fee. So POS mechanism has its own pros and cons, and actually the implementations are quite complex. So mostly, most of the applications are preferring either proof of work or the that is dedicated proof of stack. So the next is dedicated proof of stack. It is very different from POS, that is proof of stack. Here, the token holder don't work on validity of the block by themselves, but they select delegates to do validation for them. In a DPoS system, there are usually in between 21 to 100 selected delegates. The selected delegates are being changed periodically and assigned an order to deliver their blocks. So if we have less number of delegates, it allows them to organize themselves efficiently and create a design time slot to publish blocks. If the delegates miss their blocks on a regular basis or publish invalid transaction, the token holders vote them out and replace them with some other selected delegates. So, unlike POW or POS, in DPoS, miners can collaborate to develop blocks with a collaborative effort and partially centralized process. DPoS has been able to run order of magnitude which are faster than any other consensus algorithm. So, other than these three, we have a lot more consensus algorithm such as proof of capacity, proof of activity, proof of bound, then unique node list. Okay, so these are some of the other consensus algorithms which are practiced in real time example. Okay, so next is like use cases of blockchain. Okay, so before going to that, I would like to show the demonstration. If I started, it takes more time. So I'll move on to the showing of demonstration of a local blockchain. Okay, actually, it is the application of voting mechanism system. First, let me explain. Okay, for a minute, I will stop my presentation. Do you have any doubts so far? You can ask. Yes, I hope the concept is clear to you all, right? Mm, okay. I hope you all can see my screen, right? Voting system using blockchain.
Ah, yes, ma'am.
Yes, okay, thank you. Actually, first let me explain what the project is about, and then I'll show you the demo how to execute blockchain in a local network. Okay. The objective of the project is to create a voting system which ensure the fairness and transparency in the election. And as you know that it offers security, immutability, and verifiability. Okay, so the system architecture of this project is like we have a voter. Okay, so the voting process starts with authentication. Okay, so if you see like a credential, first it will check first it will authenticate the voter whether they are authorized person or not. Okay, so once private, that is in order to vote, casting the vote, what they supposed to do means they have to provide their private key. Okay, so first the validation of private key is done. Okay, so if the given private key is valid, then the voter is allowed to cast their vote. Okay, so here I think some noise is there. So here, the vote is recorded as a transaction. Okay, so we are doing one activity. What is that activity? Casting a vote. So the casting a vote is nothing but one transaction. For that transaction, a block is created, and that block is added to our blockchain network. Okay, so it is a peer-to-peer network. Okay, so here the contract, as I said, no, the smart contract is nothing but it is a software code. Okay, so here some action is happen, it will trigger the other action, right? When a voter casts the vote, automatically the vote has to be uploaded in the blockchain. So that is the smart contract here. Okay, so for this particular project, we have considered two smart contract. One is for voting purpose, and another one is identity verification. There are two smart contracts created for this project. Okay, and once the smart contract executed the transaction, the transaction is completed, then a new block is added to the already existing blockchain network. Okay, so we have block set of blocks, right? Vote one, two, three, right? Okay, so whenever the voter casting the vote, okay, a block is created, and that block is added to the existing blockchain. Okay, so this is the architecture of your voting mechanism. So here, these things like the design considerations or e-voting system should verify the identity of voters and authenticate only eligible voters. And any voter should get only a single chance to vote. That is, system should prevent double voting, and it should provide a complete privacy to voters. And the voters should not be traceable, and it should not allow tampering with the votes casted by anyone. The system should not allow single authority control on counting. Okay, so these are all the design consideration for this project and Ethereum. Okay, so we discussed about Ethereum, right? So this is one of the public blockchain technology, which is same as your Bitcoin, right? So Bitcoin, it is we can use Bitcoin for cryptocurrency application, but Ethereum can be used for any kind of application. So we preferred Ethereum blockchain network for this voting mechanism. Okay, so it is a decentralized open source blockchain featuring smart contract functionality. Okay, Ether. Okay, So Ether is the native cryptocurrency token of the Ethereum platform. That is, initially every voter or every account holder provided with a minimum amount of ether. When they perform a particular transaction on the blockchain network, they need to spend some amount of ether in order to complete their transaction. The same way for voting for this particular project also, initially every account is provided with 100 ether. Okay, so once they order, some amount, that is some ether, will be reduced from their original ether amount. Okay, so it also uses proof of work as the consensus algorithm. Okay, that is, proof of work means what? They need to solve some mathematical puzzles in order to validate the user. Okay, so solidity is nothing but it is the language. I think in the coming days you will have one session on solidity, right? Okay, so it is nothing but it is an object oriented high level language for implementing smart contract. So using solidity language, we can write smart contracts in a software code, and it is a statically typed, support inheritance, libraries, and complex user defined types. Okay, so this is a sample solidity, how the solidity software code looks. Okay, just same as your python script or javascript. Okay, so the smart contract, it are trackable and irreversible application. Once the smart contract has been deployed, nobody can edit the code or change its execution behavior. Each smart contract will be deployed at a particular address. Still, people have trust issues with the electronic vote mechanism, for which the smart contract might be the right solution. And so this is like actually the uh, contract, that is smart contract, how the smart contract is look means, like we'll be having a, like so here the hash value of your block. Okay, and then we'll have the smart bytecode of the contract, smart contract. It is appeared over here, and who has created the contract, those addresses noted here. Okay, so this is how your smart contract looks. Nobody can even look what the smart contract is about, because it is converted, it is converted as a bytecode. No one can understand what actually the smart contract is, right? Okay, then metamask. Okay, actually the metamask, it is actually the extension of google chrome. We have experience with adding more google chrome extension, right? Okay, so one of the google chrome extension is metamask. Okay, so the metamask, the purpose of having metamask is to validate the account detail. Okay, so if you want to vote, casting the vote, what you're supposed to do means, first you must have the account in metamask. Okay, so your metamask, it acts as a it just validate your account detail, whether you're authorized person or not. Okay, so it handles account management and connecting the user to the blockchain. So easiest way to interact with the app, that is your any application in the browser, and it is used for authentication, and it is easy, it is available as extension for chrome and safari browser. And so this is how your metamask looks. Okay, actually here we have we can choose a type of network. Okay, so we can have a public network or a local network. So Rockstone is example for public network, and local host. Actually, we carried out the exercise with local blockchain only. So it is local host 8545 is our blockchain network. It is created locally. That is locally in the sense your server and the client both will receive reside at a same system. Okay, then here we have like a roster that is your account details. Okay, so this is how the balance, the amount, how many ether you have in your account. Okay, so initially you will be provided with 100 ether. Whenever you are performing the transaction, it gets reduced according to the type of transaction you are performing. It get keep on reducing. Okay, so when it reaches zero, further you cannot perform any transaction on your blockchain. Okay, and this is like it is a view of all transaction associated with a particular account. Okay, implementation like a local blockchain. Okay, so the Ganache is one of the a blockchain tool. It is used to create a local blockchain. Okay, so Ganache is a personal blockchain for rapid Ethereum distributed application development, and it features both graphical user interface and command line interface. What I'm going to show the demonstration is through command line interface, because the graphical user interface it support Windows 10 and a higher version, but unfortunately, my laptop is Windows 7 only, so I could show demo through command line interface only, and using that we can simulate the blockchain network, and it is actually Ganache is used to test smart contract without requiring you to set up a real test networks, and using a remote network, and it provide 10 accounts with 10 100 ethers. I told you, no, like every account you'll be provided with 10 100 ethers, right? Okay, so through the Ganache we can create 10 user with a private unique private key, and every user can have 100 ethers in their account. And this one it's about a graphical in a graphical Ganache. It looks like the same thing, like your address and the corresponding private key, and then sorry, the address, that is current block details. Okay, so this will have the address and the balance, how many ether they have in their account. Okay, then the transaction count. So how many transaction they have done. So far they have done 4 transaction. Okay. So these details can be retrieved through your Ganache graphical user interface. Okay. Then it is previously it's about account details. Okay. So how many user the list of user account, and then their balance, and the amount of transaction they have performed. So for those details is displayed, and then block, how many blocks we have created so far. Okay, then the next is about contract. Okay, that is the smart contract. As I said, no, like for this voting application we have created two smart contract. One is the election and another one is the migration. Okay, and the address of the smart contract is displayed over here, and truffle actually. So that's all about your smart contract. That is the Ganache guy look appearance. Okay, then we have truffle. Actually, truffle is nothing but it is a development environment, or we can say it is a testing framework. Okay, so based on Ethereum blockchain, and it is designed to facilitate smooth and seamless development of DF, that is development ops. Okay, so like using the truffle, actually truffle is nothing but it is a framework. On the top of truffle only we'll be creating a local blockchain using Ganache tool, right? Okay, so without a truffle we cannot develop local chain using Ganache. Okay, so with Truffle you can compile and deploy smart contract, and also develop front end for your application, and it integrates compilation, testing, and deployment of smart contract. Okay, so this is how your Truffle looks. Okay, so here we can trace out the details like the block number, the hash of the block, then previous hash value, previous block hash value, then nonce, all the details are available in the truffle. Okay, we can retrieve the details. Okay, I'll show you like through the command line, we can retrieve the block details. I'll show you. So this is the front end of blockchain election mechanism. Okay, so here actually there are our student, they are studying final year now, Bolaji Divakar, Manuvidya and Mukesh Kumar. Okay, so this is the front end. Okay, so here the what it appears here, no, like yeah. So here your account. Okay, so your private key is displayed over here. Okay, so through your private key you can log in into the MetaMask, and then you will be provided with a blockchain front end. And then here you can select the candidate and you can press vote. Okay, I'll show you so the demo of this. Yeah. Okay. See, first, what we supposed to do means like I hope you can see my screen right in the command prompt, right? I'll just close this. So I'm just moving to the place where I have this application. Okay, so it is available in this directory only. Okay, so now I just open another because it is a client server methodology is followed here. So I need to open another command prompt for server purpose. We open another command prompt in order to start the execution of our blockchain. Okay. Um, so first, um, for generating the private keys, okay, I need to type this command test rec. Okay, so by typing this text RPC, it will generate, as I said, no, like your Ganachi, it will by default it will provide the facility for 10 users. Okay, so for 10 user, it will enable the 10 private keys. Okay, and our local host is 8545. That is what it is displayed here. Okay, so I'm just initiated the test RPC, and then I'll so here I'm going to start. I'm going to start my creation of local blockchain. Okay, so when I start this, um, I'll be it will take some time. Yeah. So it execute the smart contract. Okay, so in the browser window you'll be provided with blockchain election. Okay, so this is what the front end in the PPT I shown you, the front end, right? Okay, so that is what shown here. Now we need to log in first. Okay, so what is the tool we have used for login? The MetaMask, right? So if you see the in the Google browser window, in the right upper corner, you can see this next to your name. You can see this symbol, no? So here, as I already installed MetaMask extension in this Google browser, I'm just selecting a MetaMask here. You'll be provided with tool. So I already have a three account in this MetaMask. Okay, so now see, this is account 3. Okay, so through account 3 I have connected, and my current Ethereum value is 99.9, and as I said, no, 100 Ether. Okay, so you cannot get the whole number. Instead you'll have the 99.9987 Ether. So this is what the Ether value in your account. Okay, so when you perform the transaction, it automatically gets reduced. Okay, and it is in the connected only. So I'm just refreshing this page. It takes some time. See here, you can from in the MetaMask toolbar, you can choose what type of test network you have used. Okay, as I already said, we have used a localhost 8544. That is the port number we generated when we test the RPC. No, so if you see here, sorry, not this one. So once you started your local blockchain, all the details like your block detail, the transaction detail, and the contract created, the address of smart contract, then block number, everything is displayed over here. Okay, and I just want to show the port number that was shown earlier. So if you see here, listening on localhost 8545. So that is what displayed over here. Yeah. So now the front end it comes over here. So now what happens is, if you want to choose the person, select candidate. Okay, so we are selecting the candidate. Let's say Balaji. Okay, and one more thing, it is started like it shows like voting ends in 58 minutes. Okay, so it is added actually in the smart contract. They have mentioned the time. So once the local blockchain, that is the blockchain is started, it will be open to the user for 1 hour only. So once the it comes to end of the 1 hour, automatically the blockchain will be closed. Okay, so that is what the time. So since it is a election, we should be conscious about the timing, right? Okay, so that is why the timing is displayed over here. So I'm selecting the candidate. I'm putting vote. Okay, so before voting, you could not see the previous voter count, right? Okay, so now here it shows, that is in the MetaMask, it shows the amount of Ether will be spent for doing this transaction, for casting the vote. it will take 0.00193 ether for performing this task. Okay, so and finally you have to say confirm. Insufficient funds. Mm, some look at this one. Mm, wait a minute. I'm just rejecting this transaction. Okay, let's choose zero. Okay, let's choose another account. Mm, in account one also I have zero balance. I already done some of the transaction. That is why it is the amount is reduced. Okay, no problem. I'll add another account here. Mm, so I'm going to import a new account. So I need to copy the private value, private key value. It is actually available here. So initially we'll be provided with 10 different private keys. No, so I have to copy from this. Um, mm, if it will be in a graphical manner, it will be easy for you. Um, I'm choosing the fourth one. Just copy that private key and click import. Okay. So now you'll be provided with 100 ether. Okay. So now if you it is connected with the local host 85 portal only. Um, so now if you go to that thing, here you click MetaMask. Mm, your account is not connected. Mm, disconnect that. We have 100 ether. So now I'm just refreshing this page. So first let me check whether we are in account 3 or newly created. Okay, so we have 100 ether. Okay, so now I'm selecting the candidate. Okay. Mm, So I'm just quoting. So now we had so this is what the amount. So it is she is saying we just given a confirm. Okay. So now we have voted for Diwakar. Okay. So when the next uh, account is created, that is when the next user comes, no, that time they cannot see the vote that you have voted Diwakar, no, that they cannot see. But actually after voting, they can see their the rest of the uh, voters value. Okay, so this is how the blockchain is local blockchain is created. Okay, um, hope you understood, right, how the local blockchain is created. Not I didn't show the coding part and all. I'm just shown the demonstration. Okay, so what are the tools we can use to create a local blockchain, and how it is being accounted, that is how it is being validated, and how we can make our data for creating the block into the blockchain. Okay, so now if you see so now we have created casting an vote is one block. Okay, so if you go to this one see, this is what the transaction detail. Just now we have done one transaction. No, that detail is shown in your command prompt. Okay, so the same way if it is a graphical user interface, you just simply click on your block. The corresponding details will be displayed. Your block number, then your at what time you have done casting the vote. Okay, so what is the amount? What is the balance you have? Everything is displayed over here. And specifically if you want to use um, so this is the server is parallelly running, and it is taking care of the transaction and smart contract. Everything is accounted over here, and your server will take care of it. And here this is your blockchain detail is shown here. And this see, let's see, and here, okay, okay. So, Truffle Migrate, it is actually to compile and deploy the smart contract. And if you want, like your contract is compiling and it is executed. Okay. So now, if you want to specifically get the details about a blog, then we can use console. We need to get into the Truffle console. Truffle. Um, Truffle console. So you'll be like your if you have experience with Python programming, and you for doing your Python program, you'll be separately provided with the prompt, right? Okay. So the same way Truffle also, when you give a Truffle console, you'll be provided with a separate prompt for executing the Truffle commands. Okay. So the Truffle development and the prompt symbol. Okay. So now if I want to get the account detail. Okay, so what are the account is created for this particular blockchain network? Then you can type the command as a web3 dot eth dot get block. Okay, get account, get accounts. Okay, so when actually web3 is nothing but it is a library which have a set of scripting in it in order to it is used to obtain various block details. Okay, so for that it has a collection of libraries using which we can obtain the details about the block. Okay, So when we type web3.eth and get accounts, then these are all the accounts we have inside our local blockchain. Okay, so the same key. So when we type test RPC, you'll be provided with 10 private keys, right? Okay, so that will be displayed over here. Okay, so if you want to display, if you want to know the current block, in which block we have currently, so for that you can use command as web3.eth dot okay block number. Okay, so we are in the fifth block. Okay, then if you want to know the block detail by specifying, for example, let's say we want to know all the details about block 5. Okay, so for that we can give web3 dot eth dot um, get block of 5, because that is the block we are going to explore, right? Let's say this. So these are all the details like your block number, hash. I hope you can see somewhat, right. Okay, you can. I know that you cannot see clearly, but in the highlighting things you can see, like number, the hash value, then the previous hash, previous hash, previous block hash value, then nonce. Okay, so the nonce is nothing but a number of ones. Okay, actually, this field it plays a major role in calculating the hash value. Okay, so it has some values. Based on that, your data in a block. Okay, so both is computed together in order to generate hash value. Okay, then the transaction root, state root. Okay, so these are all the various details available in every block. Okay, that is the gas limit, then the timestamp at what time we have performed this transaction in this block. Okay, every details will be obtained from this. Okay, so this is how you can explore each and every block in your blockchain network. Okay, any doubts so far? I just simply demonstrated how the local chain is being created, and how the block is created. Whenever we perform the transaction, the block is created, and the corresponding how to explore the content of every block. So that is what I have shown now. Any doubt? I'll start my presentation for 1 minute. Yeah. Any doubts so far? Yes, Kylie, how about the time?
Do you want any more? Or shall we wind up?
Yeah, I have one more like use cases. We have various use cases. It is available in the PPT itself. I can see it. No need to explain and all. I just could quickly go through those use cases for. If you give me a couple of minutes, then I can quickly
Uh,
go through those slides.
okay, you will take another five or
Okay.
10 minutes and complete it.
Yeah.
Okay.
Yeah. I start here only, right? Um, yeah, various use cases of blockchain, like it is not only, as I said, no, like only during the year 2008, it is meant only for cryptocurrency with the help of Bitcoin. But after 2013 15, most of the applications are trying to adopt blockchain technologies into in it. Okay, so that is these are the some of the applications where the blockchain plays a major role. The healthcare, supply chain management, voting, as we just we know Sasana, voting mechanism, real estate processing, personal identity security, uh, then yeah, COVID 19. Okay, so like we have certain challenges in COVID-19, right? So like how prepared the world's health system, tracking infectious patients, then developing data diagnostics, vaccines, and targeted therapies. Then information spread through social media platform. Sometimes, no, they in the social media platform. More lot of rumors about COVID-19 are spreading. How to stop those kind of activities? Then no adequate measure to adopt in a crisis situations. Okay, so these are the major challenges we are facing in the pandemic situation, right? Okay, so can blockchain help in preventing this pandemics? Actually, we can. We can able to we can provide a solution to this COVID-19 using blockchain technology, securing medical supply chains, crisis management, tracking infectious disease outbreaks, then donation tracking. Okay, so everything can be done through your blockchain applications. Then in the use cases, okay, like healthcare. Okay, so when we say healthcare, the issues like lack of complete understanding of patient medical history, it is very difficult to understand. See if the patient is consulting with one doctor, if they are not satisfied, then they'll be move on to the next doctor. Then they don't have much knowledge on the particular patient, right? Okay, so then they'll give some wrong medicine. These are some of the issues we have with respect to healthcare. Then fake medicines are provided to the patient. Okay, so these issues can be solved through blockchain. So blockchain, the role of blockchain in healthcare is it serves as a tamper proof and get a better idea of patient medical history. And we can tag and track drugs in supply chain management. See, mostly the medicine, if you are purchasing through online, how you are ensure the validity or the information available on the medicine cover. The expiry date is there, then from which product, from which manufacturer we are buying the product. Okay, so how will you ensure those information? It is very difficult. No, sometimes some fake informations are there in the medicine cover, in the medicine box, right? Okay, so when we implement a blockchain, we cannot have such a invalid information or a fake information on your blog. Okay, so that kind of security and truth informations we can provide through the blockchain technology. Okay, then these are the like organizations, they provide a blockchain technology for healthcare field. Robomed and Passionary, they are the organization. They provide a solution for blockchain technology, like a solution for issues in healthcare using blockchain technology. And we have supply chain management, the lack of transparency, product authenticity. Okay, so these are the issues we have with respect to supply chain management. And the blockchain will provide like every product is tagged and assigned. Then tracking important product information, verify the authenticity of purchased goods. Okay, so through this kind of manner, the blockchain will provide a solution to the issues available in supply chain management. And we have voting mechanism, we discussed already. Then we have personal identity security. Um, the issues with respect to personal identity security are inaccessibility, data insecurity, then fraudulent identities. Okay, so these can be solved by having decentralized identifiers, identity management, then embedded encryption. So these are only some of the methodology provided by your blockchain technology. Okay, then the real estate processing, right? So here the issues like high fees for a third party platform, then physical proof of identity is very difficult. Then property management is very complex in the normal real estate processing. By incorporating blockchain technology into it, then we can, since we have decentralized database and the digital identity, then we have smart contracts. These issues can be solved. Okay, so then other use cases like Internet of Things, that is what your STTP, right? Internet of Things and blockchain. Then you will get more knowledge about IoT and blockchain in the upcoming days, right? So intellectual property, food safety. Okay, in any applications we can adopt a blockchain technology into it. And conclusion, blockchain is making the impossible as possible by allowing people to secure a digital relationship. Then the arrival of blockchain and the data is now being recorded, disclosed, and secured differently. Due to its tremendous potential, the blockchain is being leveraged by many smart and innovative companies for enhancing their business processes and eventually becoming the business leader of their respective industries. And the blockchain technology is immutable and cryptographically secure by eliminating any third parties, and it is impossible to tamper with uh, with the blockchain system, as it would be necessary to tamper with all of its blocks, recalculate the proof of work for each block, and also control more than 50% of all the nodes in a peer-to-peer network. Mm, yeah, that's all from my side. Um, Yeah, finally, I just end with quotation like the old question: is it in the database? Will be replaced by is it on the blockchain? Okay, so that is the future of our blockchain. And I have one more quote also: like everything will be tokenized and connected by a blockchain one day. It is said by Fred Erasmus. Yeah, that's all from these are all my references. Yes, yeah, start.
Participants, if you're having any doubt, kindly post it in the chat box or you may ask it.
Yeah. When a new transaction is processed, every node adds information about it to the ledger. In this way, payment history increases. So, how it is handled? Actually, it is one of the disadvantage only in blockchain, because every time when we perform the transaction or when we add a new block, the rest of the block has to be updated, right? But in though it is the transaction cost is high, but security is increased. So that is in the blockchain we can mainly they concentrate on the security and the scalability issues. So if you are developing the original blockchain network, there won't be any problem with respect to scalability. So what I have shown here is like a local blockchain. Using the Ganachi, we can create users up to 10 user only. But if you in the real time manner, if you create a local chain, there won't be any problem with respect to scalability. Am I answered your question, Swaroprani? Yeah.
Yeah. Any other questions? Any other questions from participants? Okay. Thank you, ma'am. It was really a valuable session for all of us, and hope all participants clear their doubts. Your talk on blockchain will be useful for every participant. was really an impressive session with required details for the beginners of blockchain. We are sure that all the participants would have attained a good knowledge on the different types of blockchain, key features, working process, core components, consensus algorithms, structures, proof of work, proof of stake, use cases of blockchain, your examples shown and other concepts. So once again, we thank you for your valuable inputs, which really will improve our ideas on blockchain. We are eagerly looking forward for more such interactions in the coming years to come.
Yes.
And thank you, ma'am. So far, thank you for accepting our invitation for this STTP.
Yeah.
Also, participants, thank you for being here today. So hope this continues in the forthcoming sessions also. Let's meet tomorrow's session by 10 a.m. Thank you. Thank you all. Thank you,
So
ma'am.
thank you all for a patient listening. I hope uh, I have opened your eyes about regarding the blockchain technologies. Is it so right?
Yeah, really.
Yeah. Thank you, ma'am. Thank you once again for our HOD ma'am, Vega ma'am, and Kyle Billy and Lata Jyoti ma'am for giving me this opportunity.
Uh,
Yeah.
Thank you, ma'am. Thank you all. So let's wind up the session now. Thank
Yeah.
you, everyone. Thank you. Let's see tomorrow at 10 p.m. Thank you all.
Thank you, madam. Thank you.